This video will review for Polynomials Quiz 2. Question 1. We're given the polynomial negative 3x to the third plus 8x minus 1. We're going to be told to find the maximum, minimum, x-intercepts, y-intercepts, increasing and decreasing intervals, positive and negative intervals, and the end behavior. So to solve this problem, we'll use Desmos. Let's clear out what I had from the last video. And we're just going to type in our equation. Negative 3x up to the third plus 8x minus 1. Oops, 1. And we're going to change our window to our standard 10 by 10 window. So we'll change our x-axis to negative 10 to positive 10. And we're going to change our y-axis the same, negative 10 to positive 10. And we can see a much better window now. So we can rate this actually in Desmos. So we have our y-intercept, so we can just type that in, 0, negative 1. Y-intercept Okay, so apparently it's wanting to do integration, so we're just going to type it in using the keyboard. So on the letter Y, and then I-N-T, still doing the same thing. So we'll just type it in Y. We'll do it like that. Y-intercept will be just 0, negative 1. The x-intercepts, oops. Let's do it like this. Let's do it as a note. That might work better. So note y-intercept. There we go. Now we got it working. 0, negative 1. Enter. We'll add another note. X-intercepts. We're going to click and grab them now. Negative 1.629, 0. Negative 1.692, 0. Close your parentheses. 0.126, 0. And 1.566, 0. We also want our maximum min. So we'll add another note. So our maximum would be 0.943, 4.028. And let's just check and confirm we got the right coordinates. 0.943, 4.028, good. Now we're going to add in our minimum. click on it. Negative 0.943 and negative 6.028. Negative 6.028. So we have our y-intercept, x-intercepts, maximum, minimum. Now we're going to add in our increasing and decreasing intervals. So we're adding a note. Increasing. So if we look at our graph, as we move from left to right, it decreases down towards a min, then it starts to increase, and it decreases. So it decreases from the min to the max. So we're just going to write in the coordinates. So negative 0.943 to positive 0.943. Now you want our decreasing. Add another note. Decreasing. So there's two intervals. So first we're going to start with negative infinity. So negative, and let's see if we can find infinity. Don't see the infinity symbol. So I'll just put 2 zeros. Oops. So use 0, 0 for infinity to our min. Negative 0.943. And also from positive 0.943 to positive infinity. Okay, now we want our positive and negative intervals. So our positive, we're at a note. So positive, we're above the x-axis. So that'd be from negative infinity to our first 0, which is negative 1.629, 692 rather. Negative infinity to negative 1.692. And also from 0.126 to 1.566. So we're just using our zeros. Comma 1.566. Now we're going to add in our negative interval. And that would be from negative 1.692 to 0.126. The reason being because we're below the x-axis over that interval. So negative 1.692 to 0.126. And the last negative interval would be from 1.566 to positive infinity. 1.566 to positive infinity. Last but not least is our end behavior. So our end behavior as we go far to the left, or as x approaches negative infinity, y approaches, or f of x approaches positive infinity. So x, draw an arrow, negative infinity, f of x approaches positive infinity. And we'll add a comma, x approaches positive infinity, f of x approaches negative infinity, because on the right side it's going down. So the only thing we have left to do is we're just going to save our graph. So make sure next you're going to log into your Desmos account. I'll save this graph. We can call it problem 1. Save. And then we want to share it. So we're going to copy it. And we can just paste it the link right into problem 1, and we're done. Problem 2. It's very similar to problem 1. This time we're getting a polynomial 5x squared minus 7x minus 3. So we're going to go back to Desmos and we're going to change out the graph. So 5x up to the second power minus 7x minus 3. Okay, so we're just going to change everything out. We already typed everything in the last problem, so we're just going to change it out. Our y-intercept 0, negative 3. Our x-intercept is going to be negative 0.344, comma 0. 0.344, comma 0. And we also have one at 1.744, comma 0. We only have 2 zeros, so we don't need this third one. We can just delete that out. Okay, we don't have a maxima, so we're just going to type in the word none. We have a minimum at 0.7, comma negative 5.45. Okay, now our increasing and decreasing intervals. So we're increasing from 0.7 to infinity. So that's from the min to infinity, 0.7 to infinity. And we're decreasing from negative infinity to 0.7. So we take out the second interval and just add in the point 0.7. So again, we're using negative 0 for infinity. So we're positive from negative infinity to negative 0.344. So change that out. And also from 1.744 to 0. 1.744 to positive infinity. We have a negative interval between the zeros, so negative 0.344 to 1.744. To 1.744. And then our end behavior as we go farther left, or approach negative infinity, we're approaching positive infinity. And on the right side, as x approaches positive infinity, it's also approaching positive infinity. So x approaches negative infinity, f of x approaches positive infinity. That's fine. X approaches positive infinity, f of x approaches, we need to take that negative out. Positive infinity. And we're done. We're going to save this one as problem 2. So if we need to come back, we can come back. We're going to close this out. we're going to share the graph, grab the link, and just copy and paste that right into problem 2. And we're done problem 2. Question 3 is asking how many distinct zeros I have. So in other words, if we were to set this each of these functions equal to 0, how many different zeros would I have? So we have 2 sets of parentheses in the first one, so that would be 2 distinct zeros. The second one just has 1 set of parentheses, that's 1 distinct 0. The third one has 1, 2, 3, 4 different parentheses, so that would be 4 distinct zeros. And then the last one, you have the x plus 1, 3, x minus 4, and x minus 5. So 1, 2, 3, 4. 4 distinct zeros. And we're done with question number 3. Question number 4. We're given 2 functions and we're asked to get the end behavior. So we already have the first part given to us. We have x approaches negative infinity. We're trying to figure out what f of x approaches. So our first function is negative 2x squared plus 8x plus 1. So see if we can copy and paste this into Desmos. Control V allows us to kind of paste it. So we just have to change this to a square. So we have negative 2x squared plus 8x plus 1. So on the left side it's going down, and on the right side it's also going down. So we need 2 negative infinities. So negative infinity and a negative infinity, and we're done. Now we need to do the same thing with gx. Let's go and do gx to the third minus 9x plus 5. So we're just going to copy, and we're going to just change it out. So Control V, just change this to a third power. Okay, on the far left side, it's going down. So we need a negative infinity. On the far right side, it's going up. So we need a positive infinity. And we are done with example problem number 4. And our last problem. An engineer is designing a roller coaster for younger children. Has tried some functions to model the height of the roller coaster during the first 300 yards. She came up with the following polynomial to describe what she believed would make a fun start of the ride. H of x equals negative 3x cubed plus 34x squared minus 80x plus 50. So first we're being asked where hx is the height of the roller coaster in yards when the roller coaster is 100x yards from the beginning of the ride, blah, 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 blah. So we're being asked to find our max and mins. So all we're going to do is we're going to copy and paste this. Well, after the equal sign, copy and paste this over into Desmos. So we'll copy this. Oops. Copy it. And if you hit Control V, we can paste it just like in the last question. Just change this to a cubic power. And just change this one to a square power. So we can't quite see it. So what we're going to do is we're going to change our window a little bit. And let's just make the top go up to maybe 500. So the max y is maybe 500. So now we can see more of the graph. So now we're going to click and find our max. And it's going to be 6.098, 146.97. So 6.098, and then type in the y coordinate, 146.197. And then we're asked to explain what it's meaning. So basically, we're talking about a roller coaster. So you're just saying top of the hill. So you're top of the hill of the roller coaster. Simple enough explanation. Now we want the minimum of our roller coaster. So we're just going to click on the minimum point. And if you want to see, you can slide it up a little bit so I can see it a little bit better. So that'd be 1.458, comma, negative 3.662. So just type that in, 1.458, and then negative 3.662. negative 3.662. And if the maximum's the top of the hill, the minimum's going to be the bottom of the hill. Now we want any zeros. So we have a 0 at 1.051 comma 0. 1.051 comma 0. Hit tab. Grab the next one. 1.89 comma 0. And then click and grab the last one. 8.393 comma 0. Just type that in. 8.393 comma 0. And what is this meaning? You're at ground level. That's a simple enough explanation for the zeros. Now to determine whether the function is increasing and decreasing, so stop at the last 0. So let's start with the increasing intervals. So we're increasing from the max to the min to the max. So we just want the x coordinates. So let's just highlight them. 1.458 to 6.098. All we want is the x coordinates. So it'll be 1.458 to 6.098. And what is the meaning? You're going uphill. You're on a roller coaster. Now we want our decreasing intervals. And we'll start with our y-intercept because anything past the y-intercept, we're talking about negative time. And that just doesn't make sense in the context. So we'll start with 0. And we're going to stop at the min. So 0 to 1.458. So 0 to 1.458. And we have one other, and the directions do say stop at the last 0. So from the top of the hill, so 6.098 to the last 0 at 8.393. So 6.098 to 8.393. And the meaning of decreasing is just you're going downhill. Now we want our positive and negative intervals. So positive where you're above ground, negative again where you're below ground. So starting with 0, so 0 to the first 0, which is 1.051. 0 to 1.051. Let's grab the next one. 1.89 to 8.393. 1.89 to 8.393. And the meaning of the positive intervals, you're above ground level. Then you have a negative interval. That'd be just this section right here. So 1.051, and then if we grab the point, it drops to negative, so it'll be from 1.051 to 1.89. 1.051 to 1.89. And the simple explanation is you're below ground level. And that should be a U apostrophe R. You're above ground level. And that's done. You're done question number 6, and that's the whole quiz. So hopefully this video helps you understand how to solve these questions for Polynomials Quiz 2 a little better.